one thing I wanted to say, even if it's a neural network, it doesn't change for the most part. I'm still trying to classify stuff for the most part, right? Yes, the tools change. Instead of using H2O and stuff like that, I might use TensorFlow or Caffe or Piano approach, right? And just know that there are a lot of matrix multiplications out there. That's why you have a lot of GPUs. But other than that, concepts don't change.
Are there any end games that do not run on clusters, or vice versa, that only run on clusters but don't run on, that are popular?
I mean, what I've seen so far is that, for example, if neural networks are a little bit difficult to scale to multiple clusters, just because, you actually have, like for example, when you look at linear regression or holistic regression, you're doing the same operation on a lot of data. So it's easy to scale. But when we're actually looking at neural network, it actually has compute graphs. Like, there are a lot of dependencies for the data. So the scaling becomes a little bit more difficult. So Google has implemented that feature in TensorFlow. I have not used it yet. I've used it on a single machine, and for the most part, the GPU is powerful enough that it can knock it out. I personally haven't done that, but I know that the feature is there. So overall, when I looked at H2Os of the world, the Sparks of the world, they're usually like just massively scalable, just working on x86s or ARM, or just regular CPUs.
Question. So things like Spark are really, really sexy, but all the data that I see says that data scientists spend 80% of their time actually doing data wrangling. Basically being data mungers and normalizing data. So what are the sexy tools for normalizing data and getting data right?
They give you the tools. I mean, like, for example, in Pandas or scikit-learn, there are functions that actually normalize the data for you, right? And you just have to like see, basically the x's and y's, you got to make sure that that's where the statistics comes in, right? I mean, you have to like give it in a certain range, because if something, one of the features ranges only from 0 to 1 and the other features ranges from like minus 300 to like plus 3000, that skews the data a little bit. So you got to renormalize those things and actually do it, right? So
there's a company called Trifacta, which is founded by Joe Hellerstein, who wrote the GIST index and Postgres.
Okay.
They call him the poorest. He's the only professor that hadn't made it at Berkeley, I think. It's called Trifacta, like three facts.
Yeah, so
They
the
specialize
question
in
is Trifacta, Platfora, and Datamirror are three of probably many.
Altrix.
but in the end, I mean, at the bottom line, you need to have some statistics background to know, like, okay, what you should do and what you should probably not do, right? I mean, that's where data scientist becomes valuable, because otherwise, I mean, these tools are getting so easy to use that people just throw on, say, grid search as if that's like a smart thing to do, but without understanding what parameters are actually passing in, and if something doesn't work, they don't know what happened, right? So that's where, like, understanding like fundamental statistics principles and math and things come into picture.
So would the role of a data scientist then mean, I'm not a data scientist, I'm here observing. So the role of a data scientist is to convince or to figure out an end game? In other words, the management I would work with would not know how to necessarily have an end game. You're saying sales, but that's not the only end game that you can have, right? So is the scientist responsible for suggesting end games? Is that
Yeah,
the
a
role?
lot of times, I mean, like, I've been very surprised, we have all this data, we don't even know how to monetize it, right?
Yes.
So that's where the creativity of a data scientist would come in.
That's what I wanted to, thank you.
How important then do you think domain knowledge is, right, in that setting, right? So there's two arguments, and one is you don't really need a whole lot of domain knowledge if you understand the data science, and I tend to disagree with that, but I'm interested in your opinion.
I think both are important, but I feel like, understanding the principles is important, because that kind of scales across domains. And obviously, if I go and work, for an oil firm or something like that, I don't know anything about that industry.
Yeah.
So that is the reason why I feel like data scientists it's important to connect, right? I mean, that's why the communication skills are really important here, because you know the business. If you are from that industry, you know the business. And I can basically show you what I can do, and that kind of is a conversation, right? It's not like, oh, I want to do this. Sometimes they don't know.
Yeah, that's reasonable. Thanks. Yeah.
Okay, man.
Thanks.
Anything you want to get follow-up information, or if you liked what Vish talked about, one of the things that we didn't mention in here earlier is if there's something that you're here talking about we want to know, that way we can try to convince Vish to give a longer talk maybe later in the year.
Yeah, I have like a 1 hour longer talk on this one, and I do a lot of research on TensorFlow and the tool and the models that are used on TensorFlow.
PCA,
Yeah,
a longer talk on that.
I would love to give it. I went through like 120 lectures to understand what the hell that means. I would love to give a talk on that.
Thank you, Vish.